The J.W. Marriott and Legends Private Residences is an 800,000 square foot mixed-use development combining hotel and residential, and is the first of its kind in Edmonton. Located in the heart of Canada's largest mixed-use sports and entertainment district, the J.W. Marriott is one of the most significant hotel developments in Edmonton in more than 3 decades. The hotel features 346 rooms and suites, more than 25,000 square feet of meeting and conference spaces, and the city's largest hotel ballroom at over 10,000 square feet. The J.W. Marriott occupies the lower 22 levels of the tower, with the Legends Private Residences occupying the remainder of the 56-story tower. At the time of construction, the concrete structure would take the title of the tallest tower in Edmonton. Due to its height, high modules of elasticity concrete was required to meet the wind acceleration requirements of the building's design. The concrete mix needed to reach strength requirements in an accelerated time frame to accommodate early formwork stripping. With an extremely tight construction schedule, the concrete structure portion needed to be completed within 20 months. To meet the schedule, typical hotel floors were constructed on a 5-day cycle and the smaller residential floors on a 4-day cycle. PCL, Thornton Tomasetti, Dialogue, and Lafarge all worked together to develop a concrete mix that would meet design requirements, workability for pumping and placing, and achieve early strength to allow for early formwork stripping. The team also implemented Giatec's Smart Rock in situ concrete strength testing technology to get real-time strength readings, which enabled the team to save at least 2 hours per formwork in the stripping stage. The combination of these activities allowed the project structure to meet the demanding schedule. The North American Construction Group office and warehouse is a 90,000 square foot building consisting of a warehouse, auto shop, maintenance shop, and 4 floors of offices. To enhance the overall aesthetics of the building, they used a variety of different architectural features within the concrete, such as various form liners, reveal lines, and aggregate. Construction of the building consisted of 5.5 million pounds of concrete. The 314 precast concrete panels, hollow core, decking, and steel roof systems took a total of 6 weeks to install. The building also features a glass back elevator and a concrete feature wall outside. Total construction of the building was completed in 8 months. The Shane Holmes YMCA at Rocky Ridge has gained Calgary-wide recognition as the building within a park. Through careful design, planning, and construction, the building's project team, led by GEC Architecture, RJC Consulting Engineers, and PCL Construction Management, Inc., alongside the City of Calgary, created a building that reflects the natural features and complements the building's open concept. The overall shape of the building matches its surroundings, reflecting the foothills landscape. The team used 330,000 square feet of non-typical formwork to create what was truly the foundation for this building's success. Using concrete throughout the project provided a precise base for the completion of the concrete, steel, and glulam structure. In addition, it established the undulated envelope that the facility is known for. Building on this, concrete was used throughout the facility's interior to create a space that welcomes guests, but also meets the City of Calgary's requirements for a high-traffic recreation facility. The Shane Holmes YMCA at Rocky Ridge includes ground-polished concrete floors throughout the concourse, 5 cast-in-place pools, and super-flat concrete slabs for 2 ice rinks, 3 dance studios, and a 23,000 square foot gymnasium. The team implemented a sophisticated building information modeling program to identify clashes and gaps digitally ahead of physical construction. The method led to a significant cost savings for the client and allowed the project team to successfully execute this complex 284,000 square foot facility on schedule. TELUS Sky is a twisting and modulating 224-meter tall concrete tower rising in the heart of downtown Calgary. Designed by renowned architect Bjarke Ingels, it will be the third tallest tower in Calgary and the fourth tallest in Western Canada. The building is the tallest concrete structure in Calgary and will provide the highest residential living in the city. TELUS Sky was developed on a very small lot relative to its size. In order to deliver the required number of parking stalls, the project needed 7 underground parking levels. The resulting excavation was the deepest in Calgary's history, reaching a final depth of 115 feet below grade. The twisting and stepping shape of the tower resulted in walking columns and a unique lateral load-resisting system. Transfer beams in the parkade transferred an astonishing 26 million pounds of force onto just 4 individual columns. Structural steel sections were embedded within these super columns. However, the size requirements for the columns was still enormous. In order to maximize the number of parking stalls adjacent to these columns, the project called for the use of concrete with a compressive strength of 110 MPa, a strength never before achieved in Alberta. The project team successfully designed and placed concrete that reached 110 MPa and beyond. In doing so, they set a record for the strongest commercially produced concrete in Alberta's history.